Dr. Satish Kanlekar and a team of student researchers at RIT's Thermal Analysis, Microfluidics, and Fuel Cell Laboratory are partnering with General Motors to advance fuel cell technology.
A fuel cell is an electrochemical device that uses hydrogen and oxygen to generate electricity, and the byproducts of this reaction are water and heat. The excess water needs to be removed from the cell, but the membrane of the cell needs to remain hydrated. So it's a delicate balancing act in removing the excess water to keep the cell operating efficiently, but also keeping that membrane hydrated.
The research team is conducting a series of visualization studies to provide a fundamental understanding of water transport within the cell and identify the optimal balance of water.
The previous project on the fuel cell with General Motors and funded by Department of Energy was mainly focused on identifying key issues that are going to play an important role in operating fuel cells under freezing conditions.
To gain access to all levels of the cell with optical and infrared imaging, the researchers modify the cell with transparent components.
So this is a sapphire window that we can incorporate into our cell so we can get the temperature measurements from the infrared camera as well as our visible observations with our high-speed cameras.
It's not very cheap, right?
No, it's fairly expensive. It's a lot more expensive than quartz, but since we're using mid-wave infrared, we're kind of restricted to the materials that we can use for infrared windows.
When you are designing the new cell, we want to build upon what we have already done. So, Jackie, do we have the hardware?
So the previous design utilized these transparent windows here, so that when the cell was assembled, the left-hand plate allowed us to view into the cell through these ports. So basically we're going to have to take this new sapphire and update our design such that we can still get access inside the cell and visualize the components while the cell is operating.
The modified cell represents actual automotive geometry and allows for simultaneous visualization of the anode and cathode.
So what we use here is two high-speed optical visualization cameras, and we're actually able to look inside the cell on both the anode and the cathode side simultaneously while it's operating, and that way we can visualize the two-phase flow inside the channels during operation. And our new project, we're going to sort of shift directions, and although we're keeping the visualization a center focus of this project, we have to figure out a way to incorporate some infrared imaging into the cell as well. Our aim is to understand the fundamental mechanisms behind water generation and water transport within the cell.
The studies provide General Motors with information to help optimize material selection and product design. For the students, it's an opportunity to use the most sophisticated experimental techniques and work on real industry challenges.